First of all, hello everyone. Thank you for joining us today. I would like you to welcome to this webinar, which is titled Maximizing the 5G Opportunity, How Telcos are Reinventing Their Business with Data. Now, as an introduction, my name is Vikas Mathur. I am the Vice President for Strategy at Actian Corporation. In this webinar, I'll be joined by my colleague, Emma McGradden, who's the Senior Vice President of Engineering at Actian, and I'll introduce her in more details in the later half of the webinar when she comes up with her part. But to start with, we have a very special guest today, Charlie Wade. He basically comes to us from the telecommunications industry. He's, I wouldn't call him veteran. I know he doesn't like to be called a veteran in this space, but I know he's been in the industry for 30 plus years, had major leadership roles, and is now running his own consulting firm, right? And so we found him. He's helped us a lot navigate figure out how to navigate the telco universe. And I think he has some great insight that we would love to bring out to everybody, who's able to listen to us here. Now, all right, so moving on with the agenda. So first, we will have a conversation with Charlie. In this conversation, we'll go through the insights that he brings to the table around 5G in general, as well as the way it impacts the data landscape in typical telcos. And Actian being a data company, we feel that there's a lot happening on the data side in telcos driven by 5G. So we'll try to make that more relevant in this way. And then we'll go on to Emma, who will dive a little bit deeper into the technology that we bring to the table from Actian, as well as do a live demo. So we hope the demo god smiled at us today, but yeah, there will be a live demo. And obviously we'll leave some time for questions at the end. So welcome, Charlie. I see you in the video live and well. This is good.
Thank you.
How's the day today in Toronto?
Yeah. Actually, the weather's fantastic up here. We've had this amazing summer this year, so we're very happy. So we're doing kind of well on the coronavirus up here, and we're enjoying the sunshine. So thanks for inviting me to this event. It's going to be a lot of fun.
You are totally welcome, and you have both the God shining on you guys. So in California, we are under a sweltering heat wave. Okay, over to the real meat of this webinar, right? So I know there's a lot of discussion around 5G. I mean, it has been around for the last 3-4 years, to be frank, but I think it's becoming more and more reality now. But what's your thought process around, is this, ultimately it'll come into the real telco side. Is it still high, or do you think it holds the transformative power that, the media, or if you read the articles around it, that people talk about?
Yeah, it's a great question. There is certainly a heck of a lot of hype around on 5G. We're seeing lots of marketing around 5G. It certainly is the big thing that's coming out there today. And anybody kind of familiar with the Gartner hype cycle will probably know we're somewhere kind of over. I think we're over the hump of the peak of expectations, and we're probably sliding down into kind of the trough of reality. I think if you were to really sum up the changes that happen on 5G, there are three major kind of technologies that come together that create three key items that allow us to create new solutions. One is that gigabit speed. So that be able to have a wireless connection that has multiple gigabit speed opens up a whole bunch of opportunities, especially in video, for example, augmented reality, virtual reality, those types of solutions, mobile broadband, using 5G technology to provide internet connectivity to homes and businesses without having the requirement for cables and fiber and physical infrastructure. That's significant. The second part then is there's a huge increase in reliability. It's called ultra reliable communications. This is a set of technologies that allow 5G to be much more reliable than previous generations of mobile communications. And that then allows it to be able to be used in really mission critical applications, in healthcare, in manufacturing, in emergency services. And then finally, there's this capability, you see down the bottom here, this connection density, where just the number of items, number of devices, number of users that can be connected to the network significantly increases. This is massive, massive connectivity. Even up to 1 million devices in a square kilometer. And you kind of think, well, why would I want 1 million devices in a square kilometer? Well, you can think of that in a downtown city, for example, where you want to enable street lights and traffic lights, stoplights, water meters, and so on. You're going to need massive density, but also in a factory environment, a manufacturing environment, where you've got hundreds of thousands of sensors managing that. So there's significant changes. And then where I see the opportunity, if we just go flip to the next slide, this is a piece of work actually done by Ericsson and Arthur D. Little. It's a really excellent piece of work. If anybody wants to go look it up, just go on the Ericsson website, you'll find it there. But this is, they've done a lot of research into where the opportunities lie for 5G. And you'll see on this pie chart, they are predicting that the economic value of 5G is probably around, by 2030, is $700 billion. And you can see the industries here that they believe are going to be impacted or affected by 5G technologies, from healthcare to manufacturing to energy and utilities. So, I think, there's definitely a huge amount of hype around it, but I think that's because, there's a lot of promise in terms of the set of technologies that are coming. With 5G, healthcare, we can think about how, remote healthcare is going to be transformed using high-speed, ultra-reliable connectivity. I mean, especially now, we can now open our eyes to how the necessity of that is with the pandemic that's gripped the world. The need to be able to go and have remote diagnostics, be able to consult with your doctor. Not with a lousy video connection, but with really high quality, high definition 8K video, to be able to share MRI files quickly and speedily across the network, for example, to do monitoring of patients when they aftercare, even wearables. I mean, everybody kind of has a wearable these days, a Fitbit or Apple Watch or something. Those being 5G connected or connected to the network are massive. And we could go on into manufacturing, where smart factories are going to be created, millions of sensors basically managing and monitoring the efficiency of the manufacturing capability. So overall, I think it's definitely, there is definitely hype out there, but for me, 5G has the absolute potential to transform many different businesses and even our own lives, by providing this really high speed, high density, ultra reliable connectivity.
Wow. Okay, so I'm now really intrigued. Absolutely, the healthcare thing is very relevant as of now. Yeah. Manufacturing seems to be the big thing, but for me, then I know there will be no more call drops. Is that right? I heard you say massive increase in quality, and then no Wi-Fi needed. I don't have to maintain that router at home because everything's going to go directly to my.
Well, like all technologies, Vikas, that no one technology is going to replace everything else. I think there's a absolute space for Wi-Fi. Wi-Fi 6 is coming out. It's it's here now. That provides fantastic coverage for folks. So it's not a panacea. It's not going to fix everything. But I certainly think that's it's an evolution that we're seeing that is going to make it there.
That's great. So can you also, so we talked about the opportunity, but there's always a flip side to this thing, right? Yeah. So how do you see this rolling out at telcos? What are the challenges do you see them kind of encountering? I'm sure some are already happening, right?
Yeah, and I think that's part of what the hype is about. Is there are challenges for sure. I've listed a few here for folks to see, but mostly if I think about telcos, some and there's a broad spectrum of where telcos are on the 5G deployment. The US is doing particularly well in terms of rolling out 5G technologies. Canada's a little later in the space, and Europe, and it's very different in Europe. A lot of that's down to that second point there, spectrum availability. So that's one of the big things that a lot of telcos are struggling with, is to get access to spectrum, and to pay for the spectrum. It's a huge cost. I know many places have delayed the deployment of spectrum. The other one is real physical deployment. One of the big differences between 5G and 4G, Vikas, is that 4G typically uses macro cells. So you'll see them on the side of the road, on top of buildings. You'll see the physical kind of antennas. 5G uses what we call small cell technology. So these are much smaller footprint, and thousands and thousands more of these small cells are deployed in the network. And so physical deployment is a massive challenge for lots of telcos, because they have to get permission to get those locations in which to erect the cell towers. So lots of kind of work with cities and towns to get access to lights and bus shelters and so on. But they also have to get actual wired connectivity to those cell sites. Other things that are that come up are mobile edge computing. So mobile edge computing is the ability to, and this is a really important development within 5G. It allows us to take cloud technology and deploy that, instead of being in a central cloud location, deploy it much closer to the edge of the network. And the reason why you want to do that is to reduce the latency, so that you can put the compute power and the applications not in the deep web, but actually on the edge of the network. And so therefore you can get lower latency. And that's really important for autonomous vehicles, for example, or manufacturing, where you need super fast reaction times. And so finding locations for those, getting those access to that, determining what the economic models are is a challenge for many service providers. Network complexity is, 5G networks are more complex than 4G. There are more components. There are more. We talked about more cell sites. The core of the network is virtualized and therefore has way more flexibility, but it can be more complex. There's a concept in 5G called network slicing that allows the network to be effectively sliced into various different sections for different users. So, for example, you may have one for the emergency services, and another slice for the general population, another slice for business, B2B, for example. That increases complexity and therefore solutions. Clearly, a lot of talk about security and privacy. 5G, because there are more things, it has more likelihood of there being, there's more attack vectors that are exposed to the bad guys. And so security is important to be really, really locked down and really thought about. And especially if you start to then deploy it into healthcare, for example, or energy sectors. We really wouldn't want, the hackers to get into, or, rogue nations or whatever, to get into our energy networks, or to get into our healthcare systems, or even start controlling autonomous drones. And then the last thing, I guess, which is important for us here, is that just the physical data that comes out of these networks. It's just enormous. We're talking hundreds to 1,000 times more data than is produced today. And so, that is a massive challenge for the telcos to manage, because data today is already very voluminous. It is the struggling. Many telcos struggle to deal with the amount of data that they have on their network and the amount of information they have. But now we're adding billions of devices through the technology. We have a real challenge with data overload. So those are some of the challenges. I mean, there are others, but if I think about it, those are the big ones that really kind of come top of mind to me.
I'm glad you bucketed them like this, right? Because I think it's good to think of them in these buckets, and each one of them seems to be quite significant to overcome, right? And no wonder we've been talking about it for 3-4 years, but it's only now that we are seeing some of it starting to get rolled out in reality.
And we didn't even touch on the fact that actually, it costs billions to build these networks, right?
So I come from a data background. Emma comes from a data background. Can we drill in a little bit more on the data side? So you mentioned this data overload is happening because of, billions of devices getting connected into this. So can you talk a little bit more about what we're talking about here, and how would a telco how will it manifest itself inside a telco, and how would we think about dealing with it?
Got it. There are kind of three things that come to mind when I think about data overload. Number one is just the sheer number of devices, things, homes, items that are connected to the network. If we think about a typical network today, you're probably thinking of, there are tens of thousands there are millions of users. Many service providers there have 10, 20, 30 million users connected. I just saw yesterday that Vodafone announced that they had their 100th million IoT user. Now that's across multiple markets. I know, that there are many organizations there that have similar numbers, but I think that's just scratching the surface of the number of things that it be connecting to our network. And the more things you connect to the network, the more data it produces, obviously. And so, when we are connecting billions of devices to our networks, we are going to get, significantly more data flow coming through. When we're connecting, more and more homes, for example, using 5G technology to connect homes, we're adding more complexity there. And you think about every home, how many devices do we have connected to our networks at home? I mean, I know I have 20, 30 or 40 devices here at my house. Those are all creating traffic. They're all creating information that at some point may or may not flow through the network, and therefore needs to be managed, controlled, and so on. So that's the first thing. I think that, and just to give you a context, think about even on 4G, the typical cell phone, I don't know if people realize this, but the typical cell phone produces between 2,500 and 5,000 signaling messages an hour. So you think it's just sitting here doing nothing. It is constantly talking to the network and constantly negotiating, which cell tower to go to, whether it needs, an IP traffic to be transported or whatever. So there is significant. Now take that, by a network that has 100 million users, you can imagine the volume of traffic that basically gets created there. So that's one thing. The second thing really is around kind of, network complexity. We already mentioned that the number of components on the network are exploding. The number of cell towers, the number of small cells, the complexity of the technology on those cell towers that are being used to create the 5G technology. So the ability to use something called massive MIMO, so massive input, multiple in, multiple out. These are radio technologies that allow us to be able to go and cater for the number of users that we're having on our cell phone networks these days. That creates more complexity, and that then needs managing. And so network analytics is a huge source of data that are just bombarding telcos' network operation centers. Today, even in today's networks, we're seeing every day tens of terabytes of data is created out of the network. So now create a network that's got billions of devices with 20 times or 100 times as many components in it. We could see 100 terabytes of data created easily in many, many networks. So that's a huge, huge issue for network operators. And then the last area, Vikas, is really around IoT applications. IoT, Internet of Things, is where those devices, those applications, we've talked about healthcare and manufacturing, automotive, we're going to see so many things connected to the network, and everything will create data, application data. We talked about manufacturing. Manufacturing is a great example. So we're going to have thousands of devices in a manufacturing plant that are going to be connected, creating data, creating messaging, creating signaling that need to be managed by the network operator. But also the things that think about it. Think about this, not only just the manufacturing plant that gets connected to the network. The supply chain gets connected to the network. All the components coming into that manufacturing plant will be tracked using sensors, using 5G, for example. And probably, and very, very likely, the finished goods will be tracked as well. So think about it. I know a company that makes power tools, for example. You'll have 5G capability in every power tool, especially the higher end ones, because why not? Because now I can track, usage. I can track where it is. I can track for service. I can track for parts. Whole supply chain becomes incredibly important, and that becomes a huge issue.
So absolutely, yeah, you're absolutely right. I mean, this is going to be a data overload, as this slide says on top, with the terabytes and terabytes produced every day. That's interesting. Sure. And you mentioned before a little bit about that telcos are going to have to invest a lot of money. Billions was the thing. I'm assuming it's several billions.
I think it's in the trillions actually globally, but yes.
Okay, even better. So how do you think? So and I know the way telcos work is there is a whole capex model, right? So how does the ROI come about on this investment that they're making? Right?
Well,
I'm hoping data plays a role in that, but.
It does definitely play a role in it. I mean, I think the trillions invested won't be all one day. I mean, they will be. It'll be over many, many years. And the 700 billion we talked about is an annual revenue in 2030. So there'll be revenues before that. So, many mobile operators are used to making long-term bets. Different maybe from the ICT space. I've been at a number of telcos where, to be honest with you, the payback on the network was in decades. Now, I don't think that's going to be the case in 5G, but I do think that it's going to be, it will come back in it's going to take at least, a decade to pay back the investment. But I think, they're in it for the long term. This is a transformative technology we talked about, and it's super important.
Okay, this is all very exciting to hear, right? So on the one hand, hearing the whole terabytes and exabytes, I'm assuming at some point of data coming in, and that needs to be handled, is exciting to kind of to me at least, and I'm sure for Emma as well. But then the fact that there will be use cases around like what you have here, customer churn, etc., that will allow people to monetize this change. This is great.
Yeah.
Do you see? I mean, so if I go back to the title of our webinar, right? We said, how are telcos reinventing themselves? Do you think this is really a reinvention in terms of telcos? Is that where we're going?
Yeah, no, absolutely. I think there are a number of reinventions. I think there are some key things that we just touched on there in terms of that. Data becomes super important, not only because what I didn't mention, Vikas, is yes, there's lots and lots of data coming into the network. So let me just answer that before I answer this question here. But actually, data becomes more important to the telco. And it's super important that they manage data and respect data in a really cohesive manner, because there's opportunities to monetize data, especially in the IoT application space. There are huge amounts of insights that businesses can gain from the telcos on the behavior and the way that their applications and their devices are working out in the marketplace. And telcos can really add value to their customers by using that analytics and that data. But they're also, they're going to need to manage that data. The only way a 5G network is going to work is if you really take care of the data and you provide the analytics on top of it to manage it. For fraud, for example, fraud becomes a huge issue in terms of, it's already an issue today. It just becomes bigger when 5G, the more devices out there, the more chances you've got to be defrauded as a telco. And the cost of devices going, in people's hands is only going up, not down. And so making sure that, very robust fraud prevention, predictive, management's looked at, looking for outliers and so on. That's important. And then managing the network is absolutely critical as well. These hundreds of thousands of devices, the network elements need to be managed, and it's almost too much for a human to manage. And so we need advanced analytics with AI and machine learning to really help the network operators proactively and predict where faults are going to happen and proactively manage it. Now, in terms of your question on, do they have to invent themselves? Look, I think some telcos are further along than others. I think that one thing is key to me in overall. If you want to make money on 5G, if you haven't got a strong B2B capability, then that's something you really have to go look at. Because yes, there are opportunities in the B2C space, especially in augmented reality, gaming, virtual reality, esports and so on. But a lot of the opportunity is in B2B. And that requires, the telco to be a much more important capable person in terms of, actually you can go back one slide. Thank you. They're duplicates. So they require to have a really strong B2B capability, and not only just sales capability, but service design, really understanding each of those industry verticals. So telcos have to have a much better understanding of healthcare, manufacturing, and all those automotive and all those other businesses to be able to be successful in this space, to exploit the opportunity. As I've already mentioned, data and data science is critical for telcos to be successful. But if you really want to understand what's happening with your network, you really understand what's happening with your customers, you want to reduce your churn, you want to reduce the amount of acquisition costs and retention costs, mining the data and having a single source of data. Many telcos have an issue with siloed data sources. They're all over the place. You need a capability that allows you to consolidate as many data sources as you possibly can in the same place, but it needs to be high speed, and it needs to allow multiple users to have access to it. It needs to not allow users to be able to run queries quickly, to be able to figure out what's going on with the business or what's going on with the network, because you haven't got time to waste in the scale of the network we've got here. IT needs to be simplified to allow that to happen. And I guess the last thing is really around culture. Culture has to change, I think, in many telcos. Partially, the culture has to go to that B2B capability, but also to respect data and the value it has, and to be driven by data and not by kind of by anything else other than data. So, you know, there's some reinvention there for sure, because otherwise the challenge is they'll invest billions and they'll be relegated to a dumb pipe, and nobody wants to be a dumb pipe, for sure. Right?
Absolutely.
And so there's cultural changes, you know, simplifying the IT, data science required, and really, you know, I think if you've got a great B2B capability, I think you're going to be in better shape than those who don't.
Right. And these are very fundamental changes. I think a lot of other industries are also struggling with many of these, especially around becoming a data-driven culture. But with the amount of investment going into the cycle, I think telcos will definitely have to step up the game on that if they have not already. So that's
sure. Yeah.
So why don't I use this as a segue to transition to the second part of our webinar here? I think we wanted to talk about some technology as well, right? So now that we have gone top down from 5G, how it impacts the telcos, what it does for the data side, and then how you really need to now start leveraging the data to really get the ROI on the thing. So I want to move over to Emma, who's going to talk about some of the Actian technologies that can help with this. Now, we don't have a panacea that will solve everything, but I think we have something that's pretty cool and that can be quite targeted in its use for some of the data challenges that Charlie talked about. So Emma, just as an introduction, she is the Senior Vice President of Engineering at Actian. She leads all of our analytics related engineering. And she's been in the database space for, I think, 25 plus years.
28.
She wrote the code for Ingress at one point, and then she's been kind of going along with Actian since then, leading our charge on analytics and all the innovation that we bring to the market on this. So Emma, with no further ado, over to you. Help us understand what we bring to the table here.
Okay, great. Thanks, Vikas, and thanks, Charlie. That was really insightful. So for those of you who aren't familiar with Actian, we've actually been in the data space for many decades. I actually am celebrating 28 years at Actian this year. And we have over 3,000 customers around the world. Most of our customers have bet their business on our technology. Data is what drives the business, and what you'll see at the bottom of the screen is that we've got some very important telco customers as part of the customer base. So we're used in terms of using something as simple as help desk management, supply chain, defect tracking, device enablement, device activation, and so on. So lots of customers in the telco space dependent upon our technology for network management, and that's going to become an even bigger challenge, as Charlie says, as we go with 5G. We support our customers 24/7. We have multi-channel and multilingual support. We are really focused on performance, and hopefully, if time permits, you'll get to see a demo that demonstrates that, and really focus on innovation. The technology that I want to introduce you to is called Actian Avalanche, and it is a hybrid cloud data warehouse. Now, the hybrid in this case is intended to mean it can be deployed on-premise and in the cloud, and you can choose where it best suits you to deploy our technology. The experience, the technology, the performance you get, and so on is all the same. It's designed for high performance at scale. And when we talk about scale, we're talking about data volumes. And as Charlie said, we're expecting to see massive growth in data volumes, and we've built a technology to handle that. It's also the scale of the number of users that are accessing the system. You think about all of this data that's going to be generated by 5G networks, and think about all of the different people that will want to get access to that data for a variety of needs. right? And then we also talk about the scale of query complexity. You're going to see as you get more data and more data sources, to get a holistic view of what's happening to your customer within their account and so on, and you've got to bring all of these data sources together, which can mean very complex queries, and we've built a technology to address that. So three aspects to this performance at scale. We have built into the platform data integration. Actian has a long legacy in developing data integration technologies that power some of the most serious data integration challenges in the world today, including things like ADP, uses for onboarding customers. So it's everything from simple payroll, but also all of the benefits that go with that, commission systems and so on. All of this tied together with Actian data integration technology. And we've extended our data warehousing platform to include that data integration capability. As I mentioned, hybrid deployment, right? So on cloud, in premise, combination of these things, we've built a technology to address those challenges. And as with all cloud technologies, you pay only for what you use. So if you need to bump up the compute power that you're using for end of month processing, maybe you're doing your billing, you bump up compute, you pay for that compute as you're using it, and then once you get through that billing period and you go back to your regular use, you go back to the normal rate at which you're consuming those compute resources. We have a separation of storage and compute so that you only, if you're bumping your compute, you're not paying for additional storage as well. That's something that's rather cool. And then in another area of paying only for what you use is, it's very unlikely in telco that you've got a 9 to 5 Monday through Friday operation. But if you did have a project, maybe it's a data science project that you'd spun up a warehouse to support your data science team, and you wanted to, at the end of the work week, as they head home, they forget to shut down the warehouse that they've been using, we'll actually identify a period of inactivity. So you say, let's say, if the data warehouse has been inactive for an hour, I want to shut it down, and we will handle that for you. It may be that you never cease operation, so we wouldn't shut it down in that case. But it can be very handy. I know, speaking as someone with a development team that can be a bit lazy about turning out the lights and turning off the data warehouses, it's quite a handy feature for cost containment. We've designed it for simplicity, and when we show you the user interface, you'll see what that's all about. So you don't have to have a very complex schema. You don't have to build cubes. You will get cube-like performance without having to build cubes. And the other benefit of the fact that you don't have to build cubes to get that type of performance is that we have the ability to update that data in real time. So with a cube, pretty much as soon as you create a cube, and that process takes time, it's invalidated, right? Because your underlying data has changed. It's designed for commodity hardware. So you choose the hardware provider that works best for you, and we will deliver performance on that hardware like you've never seen before. And then obviously on the cloud side of things, cloud is nothing but commodity hardware at massive scale. So we perform really well in cloud too, as you'll see in the next slide. So here we have a 10 terabyte benchmark that was performed by a third party, where they compared the performance of Actian Avalanche against Amazon's Redshift and Snowflake. And what they did here was they took a TPC-H, which is a industry neutral decision support benchmark. So it's got a mix of medium to very complex queries in it. And what you see at the top set of bars in this graph here is the time it took to execute the queries within that benchmark for each of the technologies. So for Actian Avalanche, it's 349 seconds to complete all of those queries. For Snowflake, it's almost 3,000 seconds. So we're going to outperform Snowflake here by about 9x. Now, very few people are running a single user against their data warehouse, right? So we had the same benchmark performed with 20 concurrent users. So that's 20 users hitting the warehouse at the same time. Now for Actian Avalanche, for 20 users, our time went up to 1,900 seconds. For Snowflake, that time went to 21,000 seconds, right? So if performance really matters to you, we've got an incredible technology that will outperform anything that's available in the market. If cost and performance matter to you, now these I forgot to mention were run on the same hardware configuration, so it's the same underlying infrastructure. What you could do is scale back the resources that you allocate to Avalanche. cut the spend that you have for the cloud infrastructure, but still deliver greater performance than you'll get from Snowflake. So there's two levers you can pull here. There's the price lever and there's the performance lever, and you decide where it makes sense for you in that price performance battle. For the benchmark, or not the benchmark, I'm sorry, the demonstration that I'm going to do a little later, I deliberately undersized the environment so that you could see the types of performance you could get out of our lowest configured cluster. So that's going to be interesting. We've designed it, as I mentioned earlier, for supporting thousands of users. It enables data scientists and data engineers to interact with the data in a way that makes sense for them. They don't need to sample the data. They can take all of the various inputs that they need. They can run a lot of iterations on their model. The data scientists absolutely love the technology because of the performance that it can deliver. We also have very fast performing batch jobs. If you've got a lot of batch operations that run in the environment, maybe it's on an overnight job, they will perform really well. We will promise 10 times the performance of our competition. So we can go 10 times as much data as the competition and deliver on the same result set. So really a fabulous technology from the perspective of price, performance, and capability. So that previous workload, we scaled up to something that's more representative of what you would be running within your environment, right? It's not like you're going to run 22 queries and say, okay, I'm done for the day. So what we looked at in this particular graph is if we were to scale up the number of those workloads that were executed. So let's say we go to 1,000 workloads, and you look here at the cost for Actian Avalanche. It's about, and we're the blue line, it's about $50,000. Now look at Snowflake. You're up around above $400,000 for the same workload. So a significantly better price performance, a much better value being delivered to the customer. And we're so confident that we can outperform our competition quite significantly that our legal teams actually agreed to an offer whereby we guarantee that we will cut your Snowflake bill in half. So if you're using Snowflake today, or you're planning to use Snowflake in the future, take your workloads to us. We will demonstrate for you that we can deliver better performance than you're getting out of Snowflake while still cutting your bill in half. So if you're interested in learning more about this, we'd love for you to visit our website, actian.com/avalanche, where you'll see more about this particular offer, or you can directly go to our Actian Solutions Advisors team by emailing asa@actian.com, and they'll talk to you about the technology and proving it with your data and your queries. Now, we talked a lot about the need for real-time insights into the data that will be generated in 5G networks. You want to react as you understand that there's, let's say, a network bottleneck, and you need to move capacity to a particular environment. You need all of this insights in real time. So one of the unique capabilities of Actian Avalanche is that we have the ability to update the data in real time without impacting the performance of running queries. So hugely important capability and unique to Actian Avalanche. In fact, it's something that we have a number of patents on. Charlie mentioned how security and privacy are really important, and we have all of the security and privacy capabilities and compliance certifications in place that you would need to support a 5G environment, and understanding that there's a lot of sensitive information in there. You don't want that data breached, and you certainly don't want to disclose accidentally some private information. So some of the capabilities that are included would include things like all data is encrypted end to end. So whether it's right the way up until it hits your device, that data is encrypted. We also provide for dynamic data masking. So if you have sensitive information, like the credit card number that you're using to pay your account, unauthorized users will only see the last 4 digits of that credit card number so that they can confirm with you that you're talking about the same credit card. Authorized users obviously will get to see the entire number, but the rest of, apart from the 4 last digits, the rest of the credit card number would be masked by letter X is typically what's used. A lot of other capabilities on here to provide for a database data security and confirm that we can honor the privacy requirements. Just in the interest of time, we're going to move along. I mentioned earlier that the data warehouse is extended to include data integration capabilities provided by Actian Avalanche Connect. And Actian Avalanche Connect provides you the ability to get to a lot of different data sources. So that could be that you've got something as simple as a Parquet file that's sitting on S3 up there in that data lake. So it could be a Hadoop cluster, doesn't matter what it is. We've got the ability to reach into that data lake, pull out the nuggets of information that are interesting, and bring that into to Actian Avalanche through Avalanche Connect. We also have the ability to connect to SaaS applications. So maybe you're using Salesforce as your CRM system, maybe you're using NetSuite. We've got the ability to reach in there and take the information that's pertinent to your environment and pull it into Avalanche, done very easily. On the on-premise applications, because I don't think they're ever going away, we've got the ability to support things like SAP and Amdocs. Again, get the nuggets of information you need, pull it into your warehouse to maybe you're building a customer 360 solution, and we've got the ability to support all of that. We also have a set of APIs, so that if you've got custom applications that you need to connect to, we can build to that with that set of APIs that we support, as well as supporting, there's a lot happening in mobile and IoT, and that entire ecosystem being able to take data from there, whether it's a Kafka stream, Spark, whatever it may be, we have the ability to pull that into Avalanche. To the right-hand side of the graphic here, what you'll see is that for the business analyst, we provide support for all of the tools that you typically see in a business analyst environment, so whether that's Tableau or MicroStrategy, Excel, or Power BI. What we have here are just a few of the tools that we support. We've got standard ODBC and JDBC connectivity, and then where it makes sense for us to have a native connector, like with Tableau or with MicroStrategy and so on, those are all built into the environment. I talked a lot about our integration capabilities. Forgot to mention the fact that we also have support for the standard ETL and ELT tools that you may already be using in your environment. So things like Informatica and IBM Data Stage, Talent, that's all provided for in supporting the platform as well. And then for the data scientists and the data engineers, the typical set of tools that is interesting to them, like Python and Jupyter Notebooks, R and Spark and so on, 9, all provided for in the platform. As I mentioned, we can deploy on public cloud, we can deploy on-premise, and we're working right now on a VPC deployment, which gives us the ability to deploy the Actian Avalanche service inside your infrastructure on a public cloud. So we've got complete flexibility over there around where you deploy it. Just going to show you a very simple example here of the type of use case where we're interesting. So this is optimizing key points of the customer lifecycle using the data that's available to us. So in the prospecting, you want to segment the prospect base to make sure that you're identifying who are the targets that you really want to convert into a customer, and then putting together a targeted program to bring them on board. For your existing customers, obviously you want to retain your high-value customers, so you want to make sure that you've got a program in place that can figure out if they have if they're having some network issues. You want to address those very quickly. Identifying a holistic view of that customer, so that you can make sure for your high-value customers that you've got everything that you need to retain them, and that will include customer loyalty programs. So here we have a very simple 3-step process that we think of. The first is connecting to our various data sources. So it might be that you've got your account information and demographics that are stored in an on-premise database. You may have your transaction history written up in a SaaS application. You may have, you may want to scrape the web logs of the customer. Are they visiting your competitor websites, right, when they go from your pricing web pages? You want to collect all your call center information as well as social media feeds, right? Are they complaining on there about the quality of service that was delivered during the hurricane that we had in New York last week? So bringing all of those data sources together, unifying that view of the customer, analyzing that information, and then taking action upon it. all really important for retaining customers. So in the example that we have here, right, we're taking all of our data sources from the left-hand side of the screen, running it through this churn analysis process, and then, you know, for customers, if we look out to the left here, we've got low-value accounts, right? So these probably are on our basic minimum plan. Their churn probability is high. We don't care, right? They're probably costing us more to keep than we're really making money on them. So here we're not going to do any action. If we've got a customer that's got a kind of a healthy spend with us, and their churn probability is 60%, we're probably going to do a campaign around, you know, keeping that customer, right? So it might be give them a discount for the next 6 months. It might be give them a free upgrade. We can figure that out. And then we've got the high account values. This is people like me that travel the world, spending their entire time talking on the phone. And we will typically have a very high spend. Churn probability can be high if we have an unpleasant interaction with our service provider. And here you want to be very direct and, you know, go to that customer with a customized offer that you know is going to keep them. And then also for the customer segment where, again, it's a high spend with you, churn probability is a little lower. Maybe it's not quite as direct an approach, but a loyalty campaign that you want to, you know, give them some points to keep them with the network. So all of this just to say that you know, you've got a diversity of resources and data sources that you need to pull together. You need to analyze that, and you need to have an action that makes sense for a given customer segment. And we provide the ability to do that microsegmentation, to do that targeting, to keep your customers. We haven't spent any time talking about our Zen technology. This is a technology that Actian has developed to handle IoT use cases. So it's a zero administration embedded database that's got a tiny footprint. It's designed for deployment at the edge. And the really sweet thing about it is that as you're collecting all of that data at the edge, you can feed that up into Actian Avalanche for, you know, deeper analysis of the data. So an integrated solution, and if you visit the Actian.com website, you can learn more about Zen and the capabilities that we provide with that technology. One of the customer use cases that we have is a telecommunications company in France, Expandium. And what Expandium does is it provides a network analysis so that they can identify patterns of usage within the network. The example that they gave to me was, let's say that you're in Paris and there's a sports event about to happen. Sports stadiums are typically on the outskirts of a city. You'll wind up with a ton of people that are showing up at the sports event. They're all, you know, getting very excited. They're on Instagram, they're on Twitter, they're watching, you know, the last couple of games of their team. You need to bump up the network capacity quite significantly because you're going to have a huge population in that concentrated area. And then once the game is over, you want to drop that back down to whatever the regular consumption would be or capacity would be for that particular environment. And what Expandium does is it provides the ability to do that analysis, to do that traffic analysis, to move capacity to where it's required. And then once it's no longer required, to make sure that it's put back to where that needs to be. So they primarily focus on telecom networks, but they also identified that transportation networks are very similar in many regards to telecommunications networks. So it's expanded to include that information as well. Charlie was talking about, you know, collecting terabytes and tens of terabytes a day, and you know, that's the type of use case that Expandium is addressing with the Actian Avalanche technology today. So we have designed this technology to help you deal with 5G challenges, to help you increase your revenue, reduce your customer churn, and improve your network reliability, right? So being able to proactively identify needs and address those needs as they come up in real time was hugely important. So that was a bit of a flyby tour because we're very tight on time. But at this point, if you bear with me, I'm going to go through a very simple demonstration of the technology. So this is the Actian Avalanche user interface. To create a warehouse, I come in here, I give it a name. I choose the cloud environment where I want to deploy it. So today we support AWS and Azure, and we're working very excitedly on Google. We're seeing great performance out of Google Cloud, and we're excited to deliver that to market as quickly as we can. If you're interested in learning more about that or to engage on an early adopter program, please get in touch with me, emma@actian.com, because I'd love to hear from you on that. So after choosing where we want to create the network, we're going to choose a data center. I'm going to choose Ireland. We choose now the number of avalanche units, and this is our horsepower for the environment. For our production environments, the minimum environment is 8 AUs, 8 avalanche units, so it's a fairly low horsepowered environment. Think of a Honda 50 motorbike type thing. We are, we talked earlier about privacy and security, and we only allow those IP addresses that you specify to access the environment. So you would say, use my IP address. I can give it a name, a label, I should say, for that IP address. And then this idle stop is the time after which I want the warehouse to shut down if there has been no new queries seen and the last query has already completed. So by default, it's an hour that we would shut the warehouse down. So rather than go through the process of creating that, there's one I created earlier. So here we have one that I created in Azure. We're using ADLS Gen 2 for storage. As I said, it's an 8 AU environment created in the Virginia data center. And what I'm able to do now is, if I come into the built-in query editor that's part of the warehouse, I can show you that I've actually created some data that's related to a telco demonstration, and we'll get to the demonstration in a moment. But just to show you, we have in this query editor the ability to write and store queries. Here's a rather complex query that we'll talk about. But here we have the fact table that's used in my telco demo that I'm running with has 1 billion rows of data in it. So just to prove that to you, we're counting those rows, and what you'll see down here in the result is that it's 1 billion rows. Just one last thing about the Actian Avalanche is this integration. So I talked about the ability to integrate data sources. So here we have the ability to take data from Amdocs, right? So we've got a very simple interface through which we can say, here's what I want to move into the environment, and I can schedule that job to run manually or on demand, as this one is set, or at a scheduled interval. So we've got the ability to do that. So getting to the heart of the demo, the more interesting side of things. Here what we have is, I'm sorry. Oops. Yes. So here we have that fact table I talked about that was 1 billion rows. We have a number of dimension tables that hold things like, device capability, the device model numbers, and the events that we might be using, market segmentation, and so on. So we're connecting this one fact table with 10 dimension tables. Here we have within the Tableau dashboard, this is actually running on 1 billion rows of data, and here we can see, based upon the size of the text here, which is the device type that they're running. So maybe we've got 1,800 BlackBerry users soon, and I'd love a BlackBerry, and it doesn't support all the apps I have. But anyway, I'm a Samsung user. We see that there's way more Samsung users than there are BlackBerry users in our data set. We can do things like identify, which are the towers that are causing us some problems. So here we've got dropped connections per cell tower. I can dig into this and learn some more about what's happening in cell tower 804. Why are we having all of these dropped connections? What's going on with that? Here we can see cell towers that we're seeing success with. So there's 0 connection failures on cell tower 1065. So maybe I want to see what's the difference between that one and the one that's causing me all kinds of problems. We've got calls per cell tower and so on. So really fast analysis of data that's stored in, as I mentioned earlier, an 8 AU cluster. So a very small and underpowered cluster. What's more interesting here is our fraud example. Now, for the fraud example, what we've done is we've built out a custom query. It's a rather complex query whereby what we're trying to do is to identify, based upon call records, is somebody using my account illegally or fraudulently, I should say. And to do that, it's a rather complex query. This is Tableau's custom SQL editor. It's very difficult to read. So if you bear with me a second, I'd like to take you back into to Actian Avalanche, where we have a much more readable version of the query, because our query editor gives keyword highlighting and it'll do auto completion and so on. And what we're doing in this particular query is we're taking that billion row facts table here. We're joining it with itself, because what I'm trying to do is to identify, have I seen multiple calls within a given time frame coming from the same number in a geographic location that doesn't make sense. So we're doing this select from our billion row table, joining it on our billion row table, and then unioning that with another select on that billion row table, joined with the union. So a very complex query where you've got a lot of self-joins going on very large data volumes. If I run this query, though, what you'll see is that it completes in about 20 seconds. Now, I could have chosen to increase the size of my cluster. In fact, when I come in here and I look at my warehouse, I've got the ability using this where I have my 8 AU listed. I can scale this environment, and I probably should have gone with 64 or 128 AUs. I chose not to because I wanted to show just what we can do. When we talked earlier about you've got two levers to pull, right? One is price and the other is performance. What I've decided here is to focus on what I'm spending. So this query came back in 19 seconds. If you were to think about joining, self-joining of a billion row table with itself, 19 seconds is incredibly fast to complete on that operation. And what that query is being used to drive inside here is a map whereby I can say, so I've now analyzed the billion records, and what I found in, oh, I'm sorry, I forgot to show you the query result there. It looked like there was only one call in the time period that I'm looking at, I'm sorry, one phone number in the time period I'm looking at where there's an issue with the actual account, and it looks like there's some fraud going on here. So when I go into the map, what I'll see is that there was a call placed here at 7 hours and 29 seconds. A second call was placed 10 seconds later. That call was placed 5.2 miles away. And we're in the Newark airport area, around Jersey City. It's impossible, unless you were sitting on a supersonic jet, to travel that 5.24 miles as the crow flies in 10 seconds. So likely this is a fraudulent use of my phone, and I want to dig in and find out more about exactly what happened there. So it's a very simple example here where we can show that by analyzing this massive volume of data, a billion records joined with a billion records, I could identify fraud very quickly. It's simply represented across this graph here, where I can click in and say, yeah, it's unlikely that this call was made by the same person. So I can dig in and find out some more about that. So lots of examples within the data set that we can play with to find out more about what's going on in the environment. But in the interest of time, I think we turn it back over to Vikas at this point.
Thank you, Emma. This was great. I mean, awesome. I mean, all I heard was billions and billions being joined.
Right.
It's like amazing. So this is good. I think in terms of what you presented, if I was to summarize the key points for me at least, was the focus has been on ease of use and management and bringing it out, right? And then performance at scale, right, being the big thing, which is what kind of you showcased in your demo, which is, again, a big thing in this context. And the last bit, the whole security part that Charlie talked about as being something that will be very important as we get so many more attack vectors into it. The more we can layer our security and put in the pieces, I think that's great. So this is really good. Thanks a lot for doing this performance. Normally we would have done Q&A at this point, but I think we are over our time by 8 minutes. So what I would suggest is that the questions that have come in, we will respond to them over email. So in summary, I mean, I would like to first thank Charlie for his time and bringing that over, and obviously Emma for the cool demo and the presentation. I would like to invite everyone here to come visit our website. Actian.com/avalanche. I think that's what is being displayed here. We have a free trial program that runs. It's constantly running. You can come in, open an account, and within seconds you will have the same interface that Emma was showing. And you have 30 days to try it out, create your own cluster, try out the fraud example that she showed, or try out your own examples with your own data loaded into it. So please come in, try that out. Emma talked about the Snowflake thing. We have a Snowflake 50% off guarantee going on. Again, contact any of us with regards to that. And lastly, we have a live demo session that we do every Thursday at 10 a.m. Pacific. You can always come and watch that. Now, that will not be the fraud demo that Emma did. That'll be a different demo that they do. So it will be a different use case that you will get to see, and you can even ask more questions in that one. So I think this is good. I've had a great time talking to you, Charlie, and listening to Emma. I would like to thank everyone who was able to join us for this session today. And with this, we should call it a close. Thank you.
Thanks, everybody.
Thanks, everybody.
Have a great day. Bye.